Hello 3D printing friends! Today on the BV3D channel, hey, it's another printer review. This time it's Artillery's new Sidewinder X2. Stick around and we'll get into it right after this. I'm Brian and you are watching BV3D. Hi, welcome back. Hey, if you're new here and you're wanting to learn about 3D printing, 3D modeling, and other 3D printing related stuff, start now by subscribing and clicking the bell so you don't miss anything. Okay, so today we're getting a look at the new Artillery Sidewinder X2 3D printer. And a big thanks to Artillery for sending this over. The Sidewinder X2 is the successor to Artillery's Sidewinder X1 3D printer, and it has several improvements over the older model. Artillery has made a change to the spool holder, so it accommodates spools of different widths without having to adjust the distance between the two sides of it. And Artillery has added a touch probe, so the printer can detect high or low spots on the bed and compensate for them, keeping the nozzle at a consistent height. And the firmware now allows saving settings to EEPROM. This feature was missing from the X1. The cable that powers the heated bed is also improved with thicker insulation and a design that keeps the cable bending smoothly as the bed moves. The bed cable on the X1 was prone to getting a kink in it and bending back and forth in the same place, which could stress the wires inside and cause issues. Speaking of cables, there are also improvements to a signature Artillery design feature which keeps cable clutter to an absolute minimum. Yes, I'm talking about the flat flex cables on the X and Z axes. Beginning with the Sidewinder X1, Artillery's use of the flat flex cables seemed to be both a blessing and a curse. They were a blessing because of their neat appearance, but this was the curse. The X1 required the person assembling it to carefully plug in those cables. And it relied on the friction between the cable and connector to stay plugged in. It didn't have clips or bracing to help secure them. These could work loose and cause intermittent problems, and the connectors could sometimes overheat. But over time, as the Sidewinder went through various revisions, Artillery made improvements to the connections. And now with the Sidewinder X2, the flat flex cables are already plugged in at the factory and they're supported with clips. The one flex cable you still have to plug in has a much sturdier connector, and it gets plugged in almost automatically during assembly. Other changes to the printer include an injection molded top bar with Sidewinder branding and cast aluminum blocks for the Z-axis V-slot rollers. Like its predecessor, it has a 3.5-inch touchscreen. The user interface is unchanged from the X1, though a couple of extra buttons have been added to support the bed probe. It retains its filament runout sensor, dual Z-axis stepper motors, and AC-powered heated bed with that textured glass surface that releases prints when it cools. It also keeps the X1's direct drive Titan-style extruder and Volcano-style hot end. It's still a PTFE-lined hot end, so the maximum recommended printing temperature is 240 degrees Celsius. The build volume is unchanged from the X1, coming in at 300 millimeters by 300 millimeters by 400 millimeters. And it remains one of the quietest printers I've used. The fan that cools the heat sink on the hot end only runs when the nozzle's temperature is above about 50 degrees Celsius. On the majority of printers that I own, that fan is on full time whether it needs to be or not. And so when the Sidewinder X2 is cool and idle, it is 100% dead silent. Not one sound. I love that about it. Okay, so let's talk a minute about what comes in the box. There are a lot of 95% assembled printers on the market, and the Sidewinder X2 is in that category. The printer comes to you in two parts, the base and the gantry. Okay, two main parts. I guess it's a few more parts when you factor in the pieces of the spool holder. You also get a power cord and a nice Artillery branded zipper pouch with tools, a USB cable, spare flex cables, a USB flash drive, and a spare nozzle. There are also a couple of spare V-slot rollers. The tools consist of a wrench and an okay-ish set of Allen wrenches. They're basic, not the nicer ball-end kind, but at least you have them. Sadly, no flush cutters, but that's one of those things that historically Artillery hasn't included. Artillery has made assembling the X2 even easier than its predecessor. Assembly is simply a matter of bolting the gantry to the base and plugging in a couple of wires. When you're putting the gantry in place on the base, on the left side of the gantry there's a plug that needs to line up with a socket on the base. That connects nearly all the gantry's wiring to the base. After the gantry is bolted into place, assemble the spool holder and mount it at the top center of the gantry. The things remaining to plug in are the two Z-axis stepper motors and the filament runout sensor, and that is literally all there is to assembling the printer. And after that, the manual covers how to tram the bed. The manual calls this section leveling the build plate, but it doesn't have anything to do with being level with the earth. Instead, it's all about making sure that the bed is at the same level as the nozzle when the nozzle is at its zero height. There are two parts to the process. The first involves manually adjusting the knobs to set the bed to the same level as the nozzle at all four corners. And the second probes the bed with the touch probe to create what's called a mesh, which is like a topographical map of the bed's surface. It lets the printer know where the bed is higher and lower. Pay special attention to step 17, which provides a G-code command to add to your slicer's starting G-code in order for the printer to use that mesh data to compensate for the bed's slight hills and valleys. Speaking of G-code, you can use pretty much any slicing software to slice a 3D model into layers and create a G-code file for the Sidewinder X2. And the manual covers setting up Ultimaker's Cura Slicer. And while the manual covers that setup pretty well, the short version is add a non-networked printer, choose an Artillery Sidewinder X1 from the list, and change its name to Sidewinder X2. And here's where to add that G-code command to the starting G-code in Cura. On a new line after the G28 Home All Axes command, add this command, M420 space S1 space Z10. That tells the printer to use the mesh data it stored during the probing process so it can compensate for any high or low areas on the bed. And it fades that compensation out over 10 layers. By using the stored mesh, the printer doesn't have to spend time probing the bed before every print. Assuming nothing happens to the bed, like turning the bed's manual adjustment knobs or being particularly persuasive when pulling parts from the platform, you shouldn't have to do this very often. The manual also covers the basics of slicing a model and saving the G-code file to the flash drive. Then you can move the flash drive over to the printer, load some filament, and start printing. The printer's user interface is pretty straightforward. There are three main buttons on the home screen: Tools, Set, and Print. Inside the Tools menu, you can heat the nozzle and the bed, extrude filament, move the X, Y, and Z axes, home the printer, level the bed, and load and unload filament. Inside the Set menu, the File button lets you switch between using the USB flash drive and a microSD card slot. You can continue a paused print, adjust the speed of the part's cooling fan, view the firmware version, and turn off the stepper motors. And inside the Print menu, you can select a file to print. Like many 3D printers these days, the X2 has a power loss recovery feature and a filament runout sensor, which lets you know when it's time to run out and buy more filament. I like the runout sensor on this printer. The ones I usually see show a blue light when filament is present and no light when filament is not present. This one shows a green light when there's filament and red when there's not. It's a simple stop-go indicator. The filament runout detection feature works like you'd expect. When the printer detects a lack of filament, the printer pauses, beeps really loudly every 5 or 10 seconds, and waits for you to load more filament. Once you've reloaded, you can resume the print and it'll pick up where it left off. The power loss recovery feature lets you resume a print that was interrupted due to a power failure. Since the Sidewinder X2 has a bed that holds onto a print while it's hot and lets go when it's cool, you've got your best chance at this if the power outage only lasts a few minutes. Because once the bed cools down and lets go, reheating the bed doesn't make the print stick again. So for short power blips, this really can be a lifesaver, like if you're 9 hours into a 10-hour print, for example. But I tested it a couple of times and found a repeatable problem. To test, I turned the printer off while it was printing and waited about 10 seconds. When I turned the power back on and the printer asked if I wanted to resume printing, I said, "Yes, please." And the printer homed the X and Y axes and reheated the nozzle back to printing temperature and picked up printing where it left off. But it forgot to do something. It forgot to turn the bed heater back on. It ended up being dragged around the bed by the nozzle, with the end result being both sadness and failure. Now, Artillery has been good about incorporating feedback into hardware updates in the past. I suspect the same is true of issues like this, and so I'm hopeful that this will be addressed in a firmware update at some point soon. Until then, if you resume a print on the Sidewinder X2 after a power failure, check the bed temperature setting and set it back to the correct value if you need to. Okay, now I want to show you a few of the things I've printed with the Sidewinder X2. I did some of the usual things that I print for these videos and a couple of things that I don't do very often. And all of these were printed with Cura's standard quality profile for the X2 with a 0.2 millimeter layer height. So I printed a handful of retraction/stringing tests as I was getting the retraction settings dialed in. For me, a retraction amount of 1.7 millimeters at 25 millimeters per second is just about right. Here's one in yellow and one in orange, and they're about as perfect as I could want. Next, there's an XYZ calibration cube which came out really good. I see no issues with it. The surface finish is smooth on the sides and on the top. I also printed Luby 3D's Aria Dragon. I may have had the temperature a little bit on the hotter side for this filament because there was a little bit of stringing here, but that's okay. This filament was a silk color gradient PLA that I've had for a while, and I was almost at the end of the spool. I like the way it transitioned from that raspberry-ish color to the silver. It's really pretty. Next up is a Calicat printed in a matte gray PLA. I don't see any stringing on this, and the overhang on the tail looks fine. No cooling related issues there, just a nice gray cat. And here's a Benchy in the same yellow as that retraction test earlier. I don't think I could ask for a nicer Benchy. Even the little nameplate on the back is legible. The last two are printed in spiral vase mode. Vase mode? Anyway, this is Clock Spring's reciprocal vase, printed in a really nice blue silk PLA. It's really intricate and I love the design. Zero issues at all. And this is the rocket plane scaled up to the full build height of the Sidewinder X2. This is a fun one because it gets you something really big without taking too much time. At its regular 100% size, it takes about an hour to print. At this supersized size, it takes about 5 hours to print, but it came out really nice and I like it. Okay, so now that I've shown off some prints, I'd like to share some things I like about this printer. I guess checking the wiring inside a printer is kind of my jam now, so I removed the bottom panel on the printer and took a peek inside. And what did I find? Ferrules! Ferrules in all the right places. Even back on the Sidewinder X1, Artillery was putting ferrules on the high current wiring that connects to the terminal blocks on the printer's mainboard. And they're continuing to do so with the Sidewinder X2. So that makes me really happy to see that. Artillery is definitely setting a good example here. Something else I like about it is the noise level it puts out, or the lack of noise level, I should say. Artillery seems to have put a decent amount of thought into minimizing the sound. Silent stepper motor drivers are only part of it. Once a printer has those, the next loudest thing is the fans. And the power supply fans are usually the loudest out of all the fans on a 3D printer. Now, Artillery's use of an AC line-powered bed heater means the printer's power supply doesn't have to provide DC power to it. And so the power supply can be smaller. And because it's smaller, it doesn't need a fan. And because it doesn't need a fan, that's one less thing to make noise. And that really helps keep the printer quiet. Artillery cools the electronics by having a large, quiet fan on the bottom of the case, which pulls air through the vents on the sides to keep things cool inside. And the fan on the hot end's heatsink is thermally controlled. It's only on when the nozzle is above 50 degrees Celsius. And when it is on, it's not terribly loud. Even the parts cooling blower is pretty quiet. I also like that it's a bit easier to assemble than the Sidewinder X1 because the flex cables are already connected. And the one that connects the gantry to the base is a much stronger looking connector that plugs itself in when lining up the gantry during assembly. And the touch probe for the bed is also a nice touch. I've gotten really good first layers and I'm comfortable enough with it that I can start a print job and walk away. I'm not going to say I won't come back and check on it 15 minutes later, but I haven't had to keep an eagle eye on it either. And now, here are the things I don't like about this printer. The spool holder is an improvement over the Sidewinder X1's and is able to accommodate spools of various widths. But some spools don't roll well on it, and if you have a spool with a damaged or broken rim, you won't be able to use it at all. A printable adapter is available courtesy of Bjorn the Hunter on Thingiverse for those problem spools. I don't like that the power loss recovery feature forgets to turn the bed heater back on when resuming a print, so you have to remember to do that yourself. I also discovered that the printer sometimes has trouble reading the 1 GB flash drive that came with it. The printer wouldn't read the flash drive at all if it was plugged into the printer when the printer was turned on. I had to make sure it wasn't in the printer when I powered the printer up. And even when the printer could read it, sometimes it would fail on the first attempt, and then I'd have to try again. Reformatting the flash drive didn't help. Artillery is aware of that issue. Apparently they got a bad batch of flash drives that have an incompatible chipset and so don't always work reliably with the printer. So if you have that problem, Artillery says they'll replace the flash drive for you. My solution is to just use the micro SD card slot. I have a bunch of spare cards and new ones are available for well under 10 bucks. And that's all I have in the do not like category, but none of them are critical deal breakers, at least for me. So that's the Artillery Sidewinder X2. It's a nice improvement over the Sidewinder X1. Looking at the pricing on Artillery's website, the X2 is 70 bucks more than the X1. So should you rush right out and replace a perfectly good Sidewinder X1? Probably not. But if you were already thinking about buying a Sidewinder X1, or you're in the market for a 300 by 300 by 400 millimeter printer, consider the Sidewinder X2. The extra 70 bucks over the X1 gets you a quieter printer, slightly easier assembly, better wiring to the heated bed, and a bed probe that I've found to work pretty well. So thanks again to Artillery for sending this over so I could show it to you. Well, 3D printing friends, that's about all the time we have for this episode. And now that we're at the end, let's go print something cool. Hey, real quick before you go, I wanted to say thanks for being one of the super awesome people who sticks around all the way to the end, and thanks for all the likes, comments, and shares. And an especially big thanks to those who directly support what I do. You're all wonderful for doing that, and I really appreciate it. If you liked this episode, a thumbs up would be great, and if you'd like to help support the channel, check the description for ways you can do exactly that. And hey, if you haven't already subscribed, please do. It's absolutely free, and it's an excellent way to help keep me making these videos for you. Well, that's it for this one. Thanks again, and I'll see you next time here on the BV3D channel.